Hello friends, welcome to Coding Garden with CJ. Welcome to Build a Brick Breaker game with P5.js. Today I have a very special guest. Say hello, Brooks.
Hey guys, it's awesome to be on this side of the stream this time, and I'm looking forward to working with you, CJ.
Yeah, it's going to be fun. So let's kind of get right into it. So I have we came up with kind of like a to-do list of what we're going to do. I'll preface this with I have not really worked with P5.js at all. I've seen videos of it, but I haven't really sat down and just coded something up. So Brooks does have experience with it, so he'll be answering my questions and directing me to the docs where needed. But I guess if I could show real quick, like what are we building? If you've ever heard of the game Breakout on Atari, this thing where you have like a paddle at the bottom of the screen. That's like tiny. Paddle at the bottom of the screen, and then you have your bricks up top. And then a ball will hit your paddle, break the bricks, and once you break all the bricks, you win. So that's what we're going to be building today. William, welcome to the stream. Ska, welcome. Cassandra, Paradise. It's going to be a fun time. So we're going to build this game, and we got basic to-do lists. So set up the project with like a index.html and P5.js, set up a basic sketch, display the user score on the screen, get a paddle on the screen, move the paddle with the keyboard keys, get a ball on the screen, launch the ball when the game starts, bounce the ball off the edges, bounce the ball off the paddle, create one row of bricks. We've really like broken it down like one step at a time. I believe we are going to try to code it like object-oriented style, so we'll have an object for the paddle, an object for the ball, multiple objects for the multiple instances of objects for the bricks. Then we'll make it so the ball bounces off of the bricks and the brick is destroyed and your score goes up by 1. And then the game is over when all of the bricks are destroyed. And game is also over if the ball is dropped and like goes below the screen. So we'll just like reset things. We have some stretch things. We may not get to these, but if we don't, you could totally fork this code and maybe add some new features to it. So we already are doing each brick is worth 1 point. But we might do it where each row of bricks gets progressively harder. So the higher up bricks are worth more points, and it takes more hits to a brick on the higher rows to actually destroy them. Increase the speed with every brick that is broken. You get 3 lives instead of just 1, and then the game is over. You could think of lots of other things to add to the game. That's just some things that we came up with.
And one thing to add on is this is just like the basic breakout style game. What's really awesome is when you like change it, add your own types of things, make it your own game. Then it's no longer breakout. It's your own creation.
Yeah. So like break. I don't know. Basketballs.
I did one where I could move the paddle up and down. And it had lasers coming across the screen. I was trying to hit the paddle, and you had to avoid those and hit the ball at the same time.
So increased difficulty. Cool. So one thing we're actually using is this thing called Live Share. So Brooks is over on his machine over there, but he can actually see everything I type, and Brooks type something real quick.
Yeah,
so,
I could say like, hello, and that way I could be on my own computer, not actually...
Did you do something? Because I didn't see it.
Oh, man. I did. I tried.
Are we connected?
You know what? I accidentally saved it. Let's try this.
Yeah, there he is. Yeah,
okay.
So you can see in real time as Brooks is typing, and he can see me typing too. But we're gonna do everything on my machine. All right. I think we're ready, Brooks. Let's do it. So I'm going to create a index.html file.
And while you're doing that, one quick question, because I don't think I asked you beforehand. How familiar are you with like basic game making?
I am. So, story time, just because before we get into this. So, my very first job as a software engineer was working for a very large oil company. And the first project I was working on was a data visualization engine. So, they had written from scratch code for like drawing bar charts and drawing line charts and histograms and different things like that. But they were doing it on Windows. And at the time, it might still be around, but there was a framework called the XNA framework, which is a game framework for Windows. So in this big business application, we were literally using a game framework because of the graphics engine to create bar charts and stuff like that. So yeah, I'm familiar with the game loop and like the draw and update and things like that.
Awesome.
Yeah.
Well, that will make it super easy then.
Okay, so I've created index.html. Where can I find P5.js?
Oh, right. So what I like to do is just do a quick Google search for P5.js.
What about DuckDuckGo? Is that okay?
Oh, well, okay. I
Well-
kind of think they're the same thing because DuckDuckGo is really using Google behind the scenes.
No, it's not.
Isn't it?
It's using, I think, maybe Yandex or something, but it's much more private than Google.
Totally wrong about that. I thought it was.
Okay, p5js.org.
P5.js, and then we can click on download,
Download.
and then we can find the CDN from there.
Do I want complete? Oh, I don't want the zip. Do I? Okay, so I can grab the single.
Yeah, so P5 has like broken apart into many different like areas. There is like ability to manipulate the DOM, to do all sorts of other things, sound, but we can get by with just the plain old P5.
P5.js. Cool. So I saw some links on there. I clicked the CDN one, and that had links to DOM and sound and P5. but-
Exactly. There's like 5 of them or so, but we just need P5.
Cool. So I'll bring it in P5. Should I bring it in at the bottom or the top? Is there like a ready function?
I usually bring these in at the top, especially if I'm just like the game on its own, because there's no bother, like there's nothing to load in really until the game's there.
I see. So there are no elements, and we're going to create everything with P5?
Yep, we're
Okay.
going to have like, we're almost done with this index.html file. We need to add in some kind of JavaScript file that we're going to be putting all our code in.
Cool. And so I can put that at the top too.
Yep.
Main.js, do you have a preference for what you call it?
We might want to call this either Brick Breaker or main.
Let's call it Brick Breaker. And also, anyone watching at home, let me know how the sound is. We're using a new mic today, and if it needs to get louder, let me know, or if it needs to be placed in a different place, let me know too. We did some testing, but don't know for sure. Okay, so now I need a Brick Breaker.js.
Yep.
Okay, let's check some boxes though. So we got our HTML file, we got P5. Let's set up a basic sketch. What does this mean, Brooks?
Okay, so there's 2 functions that like we really need off the top, which is function setup
Okay.
and function draw. And these functions are going to be called by P5 as soon as we do them. And why are you yelling at me?
Oh, it's
it's your linter.
It's my linter, yeah.
we may want to like do something about that.
Well, and it's because these functions are never called anywhere, so it's
I
like
know,
unused
and they never
variables.
will be called by us.
Right, so we could probably set up an ESLint file and say that they're global, but we don't have to worry about that.
Okay, so then the next thing is in setup, we're going to create the canvas. P5 is using a canvas behind the scenes.
Okay.
And what dimensions can we do this in?
What do you mean, like how big?
Yeah, how big should we make this?
Like 800 by 600 or something like that?
800 by 600.
Yeah.
Now, of course, it's going to be hard to sort of tell if this is working or not because we have, like, it's going to be an empty canvas.
Mm-hmm.
But we can draw. I like to do, like, a little kind of test here.
Okay.
And do an ellipse at, let's just say 50. So 50 right, 50 down, and 50 up, 50 right. So that's...
It's like a 50 radius?
Yep, and so if we just run this,
Okay.
let's open up a web page for that.
Before we move on, William is saying, Brooks on the beers. Can you show what you're drinking? I actually I gave him a cream soda.
So, totally looks like a beer, but it is a cream soda.
Virgil's cream soda.
Yeah.
Yeah, so Brooks is not drinking any alcohol tonight. And Dusan says the sound is excellent. Good. Let us know if anything goes wrong. And another point, I think you have a totally different... Are you a two-space or two-tab person?
I am normally a two-space.
So, because my linter wants it to be like this, my linter also wants semicolons. You know what? Because we are collaborating, let's set up an ESLint file so that our editors will be on both of our sides.
Yes,
Okay.
definitely, because otherwise it's going to be
Okay, so
interesting.
If you've never done this before, you can install ESLint globally. You can do npm install -g ESLint, and then once you have ESLint, you can do ESLint -init or just init.
I think it's init.
Init. Well,
-init.
okay. ESLint -init. Cool. And it'll ask us questions about our styles. So let's not use a popular style guide. Let's just answer questions about our style. Are you using ECMA 6 features? Yeah.
Yes, we're going to use the class keyword.
Class and fat arrow. ES6 modules?
Well, that's new. We can use that in Chrome now, right?
Not without a feature flag, so I don't want to have to do that. Yeah, so
okay.
not that. Where will your code run in the browser? Do you use CommonJS? That's like require and
No, we're not using require.
yeah. Do you use JSX? No. This is my break timer. Let's take a a quick stretch. Oh, and I'm drinking passion fruit LaCroix today. So no JSX, and tabs or spaces.
It's the host choice.
Yeah, so I use tabs and single quotes for strings.
I like them.
Okay. And Unix line endings. Do we require semicolons?
That's another good question.
So if you've watched me code on this channel, I do use semicolons. Let's not do it today. I'm going to challenge myself. In what format? We'll do it in JavaScript style because I do want to add, because it will say tab, but then I think we can say a two space tab instead of a 4 space tab. ESLint rules.
Yeah, if we have the ESLint JS file, we can now go in there.
Well, I'm looking up what's the syntax for enforce consistent indentation. Indent error 2. Oh, I don't know how you set up a 2 space tab versus a 4 space tab.
So I think it's as simple as this. We just say 2. And if this works correctly, it should...
Let's try it. So if I do, let's do this like that, and then ESLint fix all auto fixable problems.
Yeah.
And I guess also if I use a semicolon, it'll complain. And then fix all auto. Yeah, okay. I think we're in business.
And if we can, let's just turn off that no undefined line.
Oh, sure. Actually, let's see if there's an ESLint P5 globals.
Oh, that would be nice.
Yeah, because ESLint config P5.js, because there's all those global things built into P5, like setup, draw, canvas, ellipse, create P, and if we can add those to our ESLint, then it won't.
Now, truth be told, P5 is really awesome because they do have the ability to namespace it and to assign it to a single variable so that you don't have to have these globals. And it wouldn't be a problem, but that is a little bit more advanced usage of P5.
Okay.
We're not going to do that today, but if you're, for example, putting this inside of a view component so that like you have a header that has, let's say, breakout plane in it, like in a background, that's actually a really cool use of P5.
So I did find this ESLint config P5.js. I'm just going to install it because you can extend it, and then I believe it should have all the built-in globals for us.
Perfect.
Okay, I think this is a good use of time. We haven't actually got it started writing a game yet, but
we haven't even checked to see if we got that circle on the screen.
yeah, but this is good. So extends ESLint. Well, I wanted to extend P5.js. Can you extend multiple?
Yes.
So do you just do like true?
I think extend takes. Extend extends. That doesn't seem right.
Well, this is what I'm thinking. Oh,
Let's try it.
Well, it's saying there's a configuration, but let's just extend P5.js. No need for recommended. Okay, now if we open, hey, no
Perfect.
no
No
errors.
errors.
All right, we're good to go. So now should we try it?
Yes.
Okay, so we have our brickbreaker JS that's being brought in there. So I'm just going to use light server. Is that cool?
Yeah. I mean, it doesn't matter. Like, we're using a CDN, and we have a circle that's 50 on the X and 50 on the Y.
Cool. Can we give the canvas a background just to see? Like,
We
where we're
can.
at? Okay.
So under draw, we can give a. Oh no! I have to reset my. I don't know why it's not.
Do you have your? I believe your tab. You need to say like use ESLint or detect from the surrounding code.
I know.
But you're just
would.
changing it to
I'm
2?
just changing it to 2. Like
Okay.
there. That's faster.
Okay.
So if I come back here, if I
Yeah.
tab, okay. So we want to just do
We're
set
paired.
the
We're
background.
collaborating.
Background.
Yeah, so I want background black or something
And-
like that.
Well, okay. So we can do black. So it'd probably be 0.
Okay.
Let's try that.
Hey.
Yeah. Yeah, so like P5 is really nice because everything you think that you can do, you usually just can.
Okay. Cool. What next?
All right, so, well, we have an ellipse. That's kind of similar to a ball.
Well, on our README, we do want to create the, well, we created the sketch. Let's display the score first.
Okay.
So, where should we store the score? Should it just be a global variable, or?
I'm thinking probably a global variable.
Okay.
That just makes it easier. We could create a class for the game, but I don't think it's that big of a deal.
Okay. So we have a player score. How can we show it on the screen?
So I always forget exactly what things are. That's why I always go back to the documentation for these.
Okay.
But let's go in to P5.
Mm-hmm.
Our documentation and
reference.
Yes, reference, and then there's a text. There's an entire section for writing things on the screen.
Cool. So yeah, text. Text size. So you can specify the text size, and then you do the text, and then I guess X and Y location.
Yeah, and there's the typography area too.
So should we do that right after where we draw the ellipse? Like text size 32, and text. We'll say score is player score.
Yeah.
And do we have access to width and height?
So the only way to really do width and height type things is probably to create our own font.
Well, I mean width and height of the canvas.
Oh, yes, we do. Just width and height.
Okay, so I want to do width minus 100 for the X and 10 for the Y. Is it X comma Y? I don't know. We'll see.
It is X comma Y.
Okay.
And it starts from top left. Oh, and you know what? We need to change the color of the font because by default it's black.
Ah, okay. So fill?
So that's probably going to be fill, unless we want the outline of it.
I think we'll just go fill and then 255. What is white? 255?
We could just do 255 and it sort of it's black and white. Okay.
Hey, that is cut off. So we have to, let's adjust it a little bit. So.
That is one interesting thing is that it does start everything off from the upper, the X and Y is from top left of both the element and from the canvas.
200. We'll do 150. Decent.
All right.
Well, actually, aren't we going to have bricks up here?
We are going to have bricks up there.
Oh, well, we'll leave the score there for now, and then...
We'll have to figure out where to put them. That is one interesting thing about canvas here is that the canvas we can't go outside of it. We can't touch any of the white part.
Okay.
But not really a huge problem. We'll figure something out with this text.
Okay.
Now, we have display score. Get a paddle on the screen. So, I'm trying to think. I actually usually like to go ball first, but let's do paddle.
Okay.
Okay. So, mind if I run this one?
Yeah, go for
this
it.
one, or do you want to do it?
Go for it. I think we do want to do object-oriented style though. So
yeah.
Create a.
So I'm gonna create a class.
Okay.
Paddle. I'm not really necessarily thinking of extending creating a whole bunch of classes and having them work with each other. I think that gets messy pretty quickly.
Okay.
But if we create our constructor here. And I don't think we're going to need to pass anything into it when we instantiate it because it's pretty much just going to be the same exact every single time.
Yeah, because there's only one paddle.
Right. So we're going to need this dot width is going to be, let's say, 100. And this dot height is going to be, I don't know, 25 or so.
Okay.
This dot color, what color paddle should we have?
I guess let's just do white, black and white, right? Or
black and white.
Yeah.
Okay. Yeah. So there is a color. There is a color function that P5 gives us that will just create a color for us.
Okay.
So we want white. That's 255, and position. This is not location. And I'm actually.
We can do width divided by 2.
We can do width by 2. I'm actually going to create a new vector.
Okay.
So, are you familiar with vectors?
Yeah. So it's coordinates, like X, Y, Z?
Yeah, X, Y, Z. So I'm going to create a 2D vector in this case, which is X and Y. And so in the X coordinate, I want it like right in the middle. So that would be width divided by 2, except it's going to start from the top left of that. So I also need to subtract half of the width. So then this dot width divided by 2 itself. So
the width of the paddle.
I know it gets a little bit interesting here.
Should this be create vector 2D?
We don't actually need. It figures out what kind of vector we need.
Okay. Based on the number of params you pass in?
Based upon the number of params.
Okay.
And then it's 25 height, so we can say height minus, let's say, 35.
So it's like 10 off the bottom.
Yeah.
Okay.
I'm actually going to close my side so I can see the entire code. There we go. And, well, that gives us, like, almost everything. I don't know what else we might need right now.
I should do it, yeah.
So let's also get, like, a display method going on here.
Okay.
And this is just going to print out to the screen, so we need to fill with this dot color. And we also need to just put a rect in, so it's going to be the X. Oh, see, I love this. Code already is telling me exactly what I need in here.
Oh, well, I can't see it on mine.
Oh,
do you
that's
have a
too bad.
P5.js plugin installed?
No, I don't.
Okay.
It literally just went out and found it.
Okay.
So this dot location dot X, this dot location dot Y.
Okay.
And then we need the width. So
This dot width.
This dot width. This dot height.
Okay.
And then we need to actually use this thing.
Okay. So can I write that code?
Go ahead.
Okay. So let's say const player paddle. I guess yeah. So we'll make it a global variable, and then that's a new paddle, and then player paddler. I guess we can just call it lowercase paddle. And then in draw, we want to say paddle.display.
Yep, that's it.
Okay, let's try it. I don't see it.
I'm going to remove that semicolon.
Oh, okay.
All right, so it didn't show up?
Yeah, I don't see it.
Oh.
Do we have... Is there... Can we inspect the canvas? Oh, I guess
yes.
Oh, paddle is not defined. What?
Const paddle equals new paddle. Paddle does display.
Oh, you know what? I'm pretty sure classes are... they have the temporal dead zone. You can't use them before they're defined. Let's define this.
Oh, you know what I usually do? Here, this.
But let's also let's just define this class in a separate file, though.
Okay, we could do that. Yeah, that's probably a good way to do.
Temporal dead zone. Look that up.
Temporal.
It's a new ES 2015 thing. Okay, so we got our paddle, and then in our index.html, we'll bring the paddle in also.
The other thing that we might want to consider is we don't necessarily want to do too many instantiations outside of setup.
Color is not defined.
Color is not defined.
Yeah, so what do we have to do for that?
I thought
You can look at
color was definitely defined. I just used it the other day.
That's a good
Okay,
Color.
there is a color. Oh, okay.
How do you...
So there is a color.
Mm-hmm. But how do we...
Looking at that, so I think what the problem is we're going to go to let paddle.
Oh, you have to create it inside
and we're going to do it inside of setup.
Because that's where it has access to those variables?
Right, because setup is sort of our document on ready for us.
I see. I see. Yeah. So it's almost So like when it's ready, the whole library has loaded, and so then we have access to the color function and things like that.
Yep. We need parentheses on that new paddle.
It'll actually work without it.
Really?
Yeah, pretty sure. Yeah. See.
I don't. I do not like that.
But yeah, I do prefer it with it. We got a paddle.
We got a paddle.
Screen. Nice. Okay. That's fun. Let's make it a little bit wider.
A little bit wider?
Yeah.
All right. Well, that's where things get it's really easy to sort of play around with this because
Yeah.
we just come in here and say, wait, I have to go to actual paddle now. And width 100, we can do 150?
Sure. Let's see what happens. Nice. I'm okay with that.
Yeah.
Okay. Let's look at our README. So we've got a paddle on the screen. Now let's move the paddle with the keyboard keys.
Yeah.
All right, this is my break timer. It's a little bit longer timer. We'll take a quick stretch. Anyone watching at home, if you have any questions or thoughts or words of encouragement, please say something in the chat. You don't have to. You can just say hello. Or throw some emojis in the chat. That would be fun, too.
I'm going to see if I can load up the chat on my
Oh,
phone
wait,
here.
Brooks is going to participate in
I'm
this.
trying not to have the audio of the stream itself hit.
Okay.
It's, hey, I've got a chat on my phone now.
Emoji. Cool. All right, I think we're ready to make this happen with the keyboard keys. Okay, so move the paddle with keyboard keys. Does I'm assuming P5 has something built in for that too?
Oh, absolutely. So let's go to the back to the reference again.
Okay.
And if we take a look at that, there is an events section.
Events.
Inside of there's a ton of key code type things. So we can do like key is pressed. I think I prefer key is down.
Key is down. So I guess let's just talk about how we're gonna do this. So when the right arrow key is down, like while it's down,
Right.
we're going to increase the X of the paddle?
In a matter of speaking, yeah.
Okay. And then when left is down, we'll decrease the X.
Right, so that way it gives that nice move to the right and left.
Okay. And well, I guess are we going to have any sort of acceleration? Or
So we could do that. We could do an acceleration. If we do an acceleration, we have to also take into account deceleration too.
So like when you press the arrow key, it starts to accelerate, but after a little bit of time, it
Right. That's a super interesting idea, but I think what I'm going to do is go in and add that to our stretch.
Okay. But so for right now, it's just like when key is down, increase X.
So like we can still use part of the acceleration deceleration that we could use, just not have to deal with friction and other things.
Okay.
So.
Cool. Cassandra is asking in the chat, have we paired before? I don't think we have, Brooks, have we?
Even when we were working together?
Did we?
I mean, you've been in a room and helped me out at the lessons, but I don't think that we actually did.
We have never contributed to the same code base, I don't think.
Yeah, especially not at the same time.
Yeah, so this is a first, but we're doing our best. Cool, yeah, so acceleration, deceleration would be cool. But yeah, I'm looking at the docs, and so there is a key pressed, key released, key is down. What should we use?
Let's use key is down.
Key is down.
Because that way we don't have to worry about like keys down and track the state of the keys.
I'm just gonna pull this from. Oh, can I not copy this? Is it an image?
That's an image.
Oh, there we go. Edit. But yeah, I want to do like that. This is kind of the code we need. So like, well, really, we need.
It's actually easy. We don't need very much. We only need one of those, which is if is key down, like right arrow, left arrow.
But we need left arrow and right arrow. Yeah.
Right, and they're constant. So they have the key codes for what they need. Just put into constant, so we don't have to remember what they are.
Okay, so throw that there. And should we do this object oriented? Say something like paddle.move left.
Yeah, that's what I'm thinking. We can do. And I'm actually thinking paddle.move and pass it like the word right.
-1?
Or in this case.
Or
we
like a string right?
Yeah, let's pass the string right, so that way we can just test to see which direction we're moving in there.
Okay. Wait, so this needs to be left. So when the left arrow goes down, we will move left.
That would be.
And then when the right arrow is down, we'll say move right.
Right, and just thinking about this, we should. Do we want to handle if both keys are pressed at the same time?
No. I guess if both keys are pressed at the same time, then
crash the game, quit everything, go home.
It'll just overwrite itself because both are down, so it'll move left right, like it'll jiggle or.
I'm just trying to decide if should we use this as an else if or just two ifs.
Yeah, let's do else if.
That way we can only move like one at a time,
right.
But it doesn't have to check twice.
Right, and it's whichever one was held down first. No. I guess in this case, left would take precedence. Like if you were going right and then held down left, that would take precedence.
Right. Okay.
Doesn't matter. We're not going to worry about that. And so, should I display the paddle after move or before move?
I don't think it really matters because there's going to be a lot of frames per second.
Okay.
if we miss one frame that it's not moving, like at the beginning of the game, I don't think people are going to care that much.
Okay, cool. So we got display. Do you want to? Wait, no, sir, not display. So we got move. Do you want to try to implement move?
Sure, let's implement move here. So move, and this is going to take in the direction.
Right.
And okay, so if the direction is right, then what do we want to do? So we have our location. I kind of want to have maybe some kind of like move speed here. So in the constructor, I'm going to say this dot speed, and this will be replaced if we ever get to that acceleration deceleration. But for right now, we're going to also create a new vector because this will allow us to use vector math.
And this is the amount of x to move when we're going right, or the amount of y to move.
Exactly.
Yeah.
So
I guess we can only move in the x direction, though, right?
One would hope in this case.
Okay. We'll still create a vector, but then we'll use math and just take the x component.
This is how we actually could have the ability to move all sorts of different directions with. But we don't have to care about that right now.
Are vectors mutable?
Vectors are mutable because it's JavaScript.
Okay.
So. In other languages, not so much. Okay, so we want, let's say, I don't know, I'm going to guess 5.
Yeah, sure.
And no y values.
No y speed.
Now, coming back here, well, if we're moving to the right, we're just adding positive numbers to x, so we don't have to do anything to the vector speed.
Okay.
So we're just going to say this dot location dot add speed.
This dot speed.
This dot speed, you're right. Now, we can do else and just say, hey, if we're calling direction and it's not right, it's probably left.
Yeah, that's fine.
Now, I can't multiply because this is mutating it. Add is changing location. So if I multiply speed by -1, speed, then right will be left.
Is there a way to clone a vector?
There is a way to clone it. I think it's actually, well, we can do clone a vector, but I can also just do off of the method, the static method on the class.
Okay.
So I can say const speed equals p5 dot vector dot molt, and we're going to put in speed and -1.
So this will make the negative version of the speed.
Right, and now I can do this dot location dot add this dot speed.
Just speed, not this dot speed.
I always get those backwards.
Yeah, so it's like, in this case, we want to use, can you see my highlight over there? Yeah,
I can.
Yeah, so in this case, we want to use our built-in speed because it's positive, and then in this case, we want to use this variable speed because it'll be negative. I guess technically, we could just store right speed and left speed.
I could store right speed and left speed.
I think let's do that because that way we don't have to calculate this every time. We can pull this up here, and we can say right speed.
Well, at this point in time, I almost might suggest a different type of.
What are you thinking?
I'm thinking we have this dot speed as an object and put right and left as keys in that object.
I'm down. Let's do it. Okay, so right will be that. And actually, then we don't even have to do multiplication. We can just say create vector with -5, right?
Yeah. Then now we just do create vector with -5.
Cool. And I think I need a comma there.
And now here, this dot speed, so these do have to change now a little bit. So this dot speed dot left. This dot speed dot right.
Okay. I just thought of another thing. So because we're passing in the direction, we could actually do this dynamically. So we could say this dot location dot speed at
direction. Yeah, you're right.
And then we get rid of this. Ho ho.
Now we're talking.
Okay.
That's super easy to read now.
Yeah, because speed has right and left, and then over here we're passing in either left or right. So then that will access the correct speed. Okay.
All right.
Are we ready?
Let's try it out. Let's see if it works. One thing I have noticed is that you can't use it until you click inside of
click in the canvas.
Hey! Now we have a moving target.
Yeah, that's decent. I think I like that speed. Maybe we'll increase it just a little bit. Let's see.
one nice thing about playability, which we're not going to get to today, but if you want to make like a really hard game, is as like things fall from the top. If you catch them with your paddle, it might change things like set the like make it so that the paddle shrinks in size, grows in size, maybe speeds up, slows down.
Ooh, this is 8 speed. I think I like that. And then one thing I did real quick, just minor refactors, like create a speed variable and then just multiply it by -1.
Yeah, that works too. Like we could also do things like pass in the speed to the paddle when we instantiate it, so that way you could do things like multiplayer someday and have different speeds.
Awesome. Okay. I think we need to stop. I need to stop refactoring so much. Like, let's just code this thing.
Okay. But we do have.
Check a box. We have moved the paddle with keyboard keys. We do have a ball, but I think we should maybe create an object for it.
Yeah. Do you want to lead? Well, I led on this last class paddle, so why don't you lead on class ball?
Yeah. Let me get rid of all my stray semicolons because I keep adding them.
Do we have? Oh, I guess you don't have on save like change, right?
No, I can fix everything one file at a time. Okay. So we want a ball. How are we doing this? You're gonna tell me what to do? Or...
Sure. Yeah, I can.
Okay.
I can drive on this. So we want a ball.
Okay.
So I think I like to do with. Let's just pretend that the ball class already exists.
Yeah.
And use it. So we'll instantiate a new ball. Except VS Code really doesn't like that.
Yeah, because it doesn't exist yet.
It doesn't exist yet.
Okay.
Okay. So all we're gonna have to do with this for right now is display the ball on the screen.
Okay. So let's create a new file called ball.js. Create a class ball. The constructor. Do we need to pass in like the location?
We could do that for right now. I'm thinking let's just have this location be right in the middle of the screen.
Okay. So this.x is width div2, and this.y.
Let's actually make these vectors.
Okay. Create vector with width divided by 2 and height divided by 2.
Yep, perfect.
And this.location.
Yeah.
Okay. And then we'll need a display or draw, or what should we call it?
Well, we'll probably also want to set the color because
Okay.
by default it's going to be whatever the last thing we printed colors was.
Okay, so this.color will be color. What color should it be?
I don't know. What color do you all want it to be? Do you have any preferences, chat?
Yeah, there's a little bit of delay in the chat, but here, let's make it white for now. But if you have any color preferences, shoot us a message and we'll make it that color. 255 is the white, right?
255 is white.
Okay, so we got it like that. We can change it if we need to. So we got a color, and now in display we should create a rectangle. So we could do fill.
So we want to fill.
With this.color, and then create a rect.
It's actually, well, do we want a square ball?
Oh,
or
sorry, an
a
ellipse.
circle?
Yeah, we want a circle ball.
Purple,
Yeah.
William says.
Cool.
I don't know what the code for purple is
Do I
right
have
this second.
Is there a color? There might be an extension in VS Code to generate like a color wheel.
Philip says pink.
What's
Cassandra says purple.
I think we have 2 votes for purple.
2 votes for purple.
Purple RGB. Look at this! DuckDuckGo gives me the nice hex code.
Nice.
Well, I can use RGB 128.0.128. Cool. So fill, and then we'll create an ellipse. Do we want to give the ball...
So it's going to be the X and Y, so we want to just put it right in the center?
Should we have like a radius?
Yeah, size would be really good for this. I'm thinking probably no more than 10.
Okay. And then ellipse takes X, Y? Or...
X, Y, and then the sizes.
Dot Y, this dot radius.
And we have to do it
radius.
twice because ellipse, I mean, it doesn't have to be a circle, but we want it to be in this case.
Right. Okay, and so now that we have a ball... Oh, Cassandra says medium purple. Let's try that. Well, let's see what it looks like this way, and then I'll add those RGBs.
Yeah.
So now we need to display it in the draw function.
Yep, then we just need to display it.
Ball.display. Oh, broke a thing. Ball is not defined. Oh, we need to add the file.
We need to bring it into index.html.
That's a tiny little ball.
Is that too small?
Yeah, I think 10 is too small.
I could...
And actually, let's get rid of that other thing we did at the beginning. Like this ellipse.
Oh, yeah, we want to get rid of that one, too.
Okay. But yeah, let's make ball like 30.
Did you notice how that other ellipse turned purple?
Ah, because we were resetting.
That was the last fill that we used was the balls.
Right.
Okay, so I also feel we might want to try to brighten that up. It was pretty dark against that black background.
Break timer. Let's take a quick stretch. Hey Bob, welcome to the stream. What's up? Yeah, I'll try light purple. See if it's a little more visible. 147, 112, and 219. Oh, and then William said the text.
Oh, yeah,
the text is purple too. I think that's okay though. Nice color, Cassandra. I like light purple.
That color for that text actually looks decently good.
Yeah, I'm okay with that. We got a ball on the screen.
All right, so we've got a ball, but we've done a lot of work now, and we don't have any motion. So
right. Well, we do have this.
Okay, but we don't have automatic motion. So I think
like the ball. You mean?
Like the ball.
Okay.
And I think that's going to be the next thing.
Okay. Let's look at our README. So we got the ball on the screen. Now launch the ball when the game starts. So does Brick Breaker work like the ball starts on your paddle and then launches from there, or does it like come in? Or?
So yeah, it couldn't be that one. Like we could start it right at the bottom and then it goes up, or we can start it and it comes down.
And you have to.
And then we have to hit it.
Okay.
So do you have a preference?
Let's start it off on the paddle.
On the paddle.
Yeah. So like when the game starts, it just like launches off of wherever the paddle is.
So we can either pass in the paddle to the ball when we create it so that it knows where to go, or we can pass in like the location and basically calculate it in that setup function.
Yeah, and so because right now the ball, it's just let's pass in the location to the ball.
Okay, cool.
Yeah.
So
we'll pass in, let me get rid of that semicolon. I will pass in location to the ball. And then when we create a ball, actually, should we pass in the location to the paddle too so we can do like a little bit of math to like move it up? Or
well, when we create the paddle, it's
it has a location.
It has a location right in the middle of the screen.
Okay.
So what we want to do,
paddle.location, but we want to increase the y by the height of the paddle.
Of the ball.
Well, so what I'm
if we start right in the middle of the paddle.
Yeah, let's see what happens if we do this. That will put it.
And the top left.
Top left, okay.
Right.
And so we want it to be in the middle and then kind
so
of like
move it to the right by about half the ball. So.
Do you have to do vector math? You wanna try it out?
Yeah. So what we probably want to do is instead of just going straight in there, we're just gonna say const ball location is going to be create vector. Oh, it doesn't create.
It's not auto-completing anymore?
It's not auto-completed for me now. Oh. Okay, so on our X, we want to just move half the distance to the right. So that's going to be the paddle.location.x plus
paddle.
half
width?
the width of the paddle width.
Paddle width.
So
paddle.width divided by 2.
Plus paddle.width divided by 2. And so that's the X, and then the Y is going to be paddle.location.y minus, because we want to go up, and half of the ball's location.
Half the ball radius.
The only problem is ball's not existing yet.
But it does have a radius.
It does have a radius.
So we can go just the radius, right?
Right. We just have to remember that if we ever change the radius again in the future...
This is why I think we should pass the paddle into the ball and do this inside of there.
Okay, let's do that.
So the ball gets the paddle, and then I think this makes a lot more sense, because that way the paddle's already been set up, and then we can do something like this.
And at this point, we could just put this here, take that, and just sort of straight up right there. There.
Okay.
Now we have.
So we need to finish off this. So it's location.y minus radius.
Minus this dot radius divided by 2.
Radius is half though. Okay.
It's half, but we want Okay.
Wait.
I can never remember whether or not it's actually is radius or not.
More of those. VS Code is being way too helpful. It had like an extra. Hey. That's
All right. Let's.
Okay. So
That looks pretty good.
Yeah. It stays there, but so when the game starts, it needs to have some.
We could just like start going right away, and the
Okay.
easiest thing to do there is we could have a velocity right
Let's
off
do
the
it.
top.
So this is this gonna be a vector?
It's gonna be another vector.
Okay.
Do we want this random or not random?
Not random to begin with.
Okay.
Will we be able to take into account like if the paddle is moving, then the like create when the ball hits, there's like some angle that it will shoot off at or something.
Yes,
like that?
we can figure that out.
Okay, but right now, like x velocity should be 0 because I don't want it to go sideways. I just want it to go up.
Well,
Or do we want it?
do we want to go straight up or off to the side too?
We should. I guess it should be random. Yeah.
Well, okay. Let's just say this. Let's
Okay.
just choose, and I accidentally
Get rid of that.
deleted something. Okay. My mouse here is doing weird things. Let's just say something like 5, -5. So go to the right and go up.
Okay.
So let's. Oh, but of course this won't work on its own because we can't just say velocity and have it like actually
We
do
need
something.
We need an update.
We need an update method.
Okay. And then this dot location
Dot add this dot velocity.
and that mutates location.
That's going to mutate the location.
Okay. And then now we'll call update.
And then we call update in the draw
Okay.
function.
So ball dot update. And again, this is like, should I update the ball before I draw it, or should I? Let's do that. Wow.
Yeah. Did it fly off the
It
screen?
just goes forever.
Well, yeah. I mean, that's sort of like what happens when we first start doing these.
Yeah, well, that's awesome.
But
Okay.
it is pretty cool, and like one thing I really like about vector math is it makes like adding of the x and y's super easy. And it's also how we can get this really, really smooth motion.
Yeah, definitely. Yeah, I love it. Let's look what's on our. Yeah, now we should bounce the ball off of the edges.
All right, so who do we want to have in charge of that? We could have just in draw do it ourselves and like tell the ball when it's hitting edges. We can have the ball do it.
Should we do like ball dot?
We can have like ball dot check edges or ball dot bounce off edges method.
Yeah, ball. I think we should do ball dot bounce because like, then inside the ball we can say if we're hitting the right wall, then x shouldn't go negative. If we're hitting the left ball, then x should go positive. If we're hitting the top, then y should go positive.
Right.
Yeah, let's do that. Whoa, apologies. So it should be bounce and
I almost think like because there's also going to be bounce off of the paddle and the bricks, and those might be the bounces might be the same, but we also want to like check to see are we hitting like who's checking to see if it's hitting the edge? Is that the ball itself or something else?
let's try with the ball right now. It feels more object oriented, but we may figure out that we need to do it elsewhere.
Okay, so let's do that here.
Yeah, so let's say like bounce edge, and you can code it up.
All right, so bounce edge. I mean, really, we have the radius, so we can use that with, and we have a width and a height.
Mhm.
So if this dot location dot x, the right hand side of it, so plus this dot radius, if that is greater than or equal to the width,
Right.
at that point in time, we just want to move left. So we don't really want to do like a full reversal velocity because that will cause weirdness with the. We just want to change the x, not the y.
Right.
So here's where we're going to mutate it, where we're going to say this dot velocity dot x times equals -1.
Okay.
And now we'll be able to do the exact same thing for the top and the left.
Let's just add a comma right here. So check right wall, right edge for that one.
All right, so else if location dot, let's just do the left-hand side.
Yeah.
So location dot x minus
This dot radius.
this dot radius
is less
than or equal to 0. This dot velocity dot x -1.
Flip it. Yep. So this checks the left edge.
Yep. And local storage location.
That checks the right edge, and then now we're gonna check the top.
Man, it doesn't like it when you're typing and I'm trying to type at the same
Okay.
time. The autocomplete was changing based upon both of ours.
Okay.
Okay, so if the y, and then we want a top part, so minus this dot radius, if that is greater than or equal to 0,
Right.
then we want, say, this dot velocity dot y times equals -1.
Cool.
All right, let's try it.
This
Let's see if we have a.
We should have like a pretty basic ball bouncing everywhere. All right, there. Oh, oh, we're not calling bounce edge, so we need to call that.
Yeah, we need to actually call bounce edge in drop.
And again, should this be before update?
I mean, there's like, it's just gonna be. It probably could be before update because it's going to apply the vector math in update.
Okay. So bounce the edge. Some really weird things are happening right now.
Oh, what?
It's just going left and right.
Hold on, let me take. Okay, so bounce edge. We're doing this. Then we're doing update. What are we doing here? What's this?
Let's log where we're bouncing off of. So right here we'll say. Well, I think what's happening is the.
Oh, let's see. No, 0. Yeah. So this location at x plus this radius.
Oh no! Here it is. The y. We need to check that to be not greater than or equal to 0, less than or equal to 0.
You're right. Yep.
Because right now it's just staying exactly where it is.
Yep, that was. if you're.
There we go.
Yeah.
Hey, look at that. Okay,
So it
but
is.
we don't have anything for the bottom.
So this type of thing I run into all the time when I'm coding and doing little game type things or anything else, and a lot of that is because I'm dyslexic, which causes those types of like switching errors. But it's also the reason why I allow them to do so little code and then test it and see if it was working because then I can self-correct really quickly.
But this makes sense because 0, 0 is top left, right?
Right, 0, 0 is top left.
And so then that means y up here is 0. And so if it ever goes less than that, then we're above it. But before we were checking if it was below it.
Right.
Cool. So that's working.
And I just want to say we have collision detection implemented in our app.
There you go. Some really basic collision detection. Like if this thing is within certain bounds, do something else. Cool. Now let's bounce the ball off of the paddle.
Okay, so this will be like very similar, but
Okay.
slightly different.
Should we have another like ball dot bounce paddle? That?
We probably do want a ball dot bounce paddle. Mine just suddenly is loading. Oh, there it is.
Oh, is it switching files when I switch files?
No, I have to switch file to follow with you.
Okay.
And it doesn't load up with the changes until I get there. Then suddenly it speeds up.
Okay.
Really, like does it all.
So
really fast.
I'm in ball.js right now.
You're in ball.js.
Yeah. So bounce paddle, and we'll have very very similar logic.
We're probably going to want to pass the paddle into the ball.
Well, we have access to the paddle in the constructor, so let's put it on this. So this dot paddle equals paddle.
Yep. So we just hold it.
Because we can then still ask for the paddle location.
Right.
So if this dot location dot x.
So I always, every single time, have to write this out like on a whiteboard. It's really, really hard not to do that.
We have a whiteboard notebook?
I have.
That's awesome.
I have a whiteboard notebook. I did not bring a Wacom tablet with me, so I can't use that. But so I want to say, if we have a ball like this, so let me make sure. Can you see that?
And
yeah, you can see that.
So paddle. Okay, go ahead.
So the idea for this is like if this is 0, 0 right here for the paddle and the screen, this might be like 0, 50, 0. And we just want to make sure if any part of the ball overlaps with any part of the paddle, we know we're impacting and we can do some kind of hit.
Right. Are we drawing the paddle? Are we drawing the paddle? Zero. The location of the paddle is the top left corner of the rectangle, or the location of the paddle is the center of the rectangle.
So
where are we drawing it?
It's drawing it at the top left. So P5 is doing top left of like our location is top left of the paddle.
Okay. So what I'm thinking is, if the current X location, I guess we should just check Y. It should never bounce off of the sides of the paddle, right?
Yeah, we could.
Well, we need to check X though to make sure.
We need to check X because we want to make sure, are we in the column? Are we in the column? And if we are in a column, then we can check, well, are we in the Y?
Okay, so if the location dot X plus the radius, which would...
The right-hand side.
Right. Is less than or equal to the X of the paddle...
We don't need that because that's the left-hand side of the paddle.
So then we should say greater than or equal to.
Right. So now we say our ball is guaranteed at this point in time to be on, and that's where it's now at least over.
Put it a little bit closer to the camera.
It's at least over here.
Right. So at least either on the edge or to the right of it. Okay.
But we also want to make sure it doesn't get over on this side too. So we need it in the middle of it.
Yeah. So if the location is greater than or equal to the X, and less than or equal to the X plus the width.
Plus, now we want to check the left side of the ball. So it's going to be minus this radius.
Okay. So X minus the radius, that's the left side of the ball. Oh, no, we want to check the right side of the ball. Okay. I don't know.
I'm thinking because we want, if the ball is like over here, we want the left side to be hitting on there.
Okay.
I don't know, I can also show.
Right. Okay, that makes sense. And so if that X is less than or equal to the X plus the width, meaning the far edge of the paddle,
right,
then that means we have a hit.
Well, it means we have a potential for a hit. Because we're in a column.
Right.
And remember, we got into that Y problem where we're just always hitting.
So this if statement right here means, we are within the width of the paddle. But then we need to check, are we also at the bottom of the screen?
Right.
Okay.
No, so is the Y hidden?
Right. So if this dot location dot Y plus this dot radius is less than or equal to this dot paddle dot Y.
And that's it.
Well, yeah. Well, no. Yeah, because the
Y
is the top left.
Yeah.
Okay. Then we need to set Y in the opposite direction.
Right, and we set Y in the opposite direction.
So this dot velocity dot multiply.
Dot Y.
Dot Y times equal -1.
Right, and we have to do that simply because if we did it the other way, the X would get multiplied too, and then it would do something weird.
Oh. Oh, am I calling bounce paddle right now? I am. Okay, so.
Did we save the files?
Everything is saved. Hard refresh. Nope, going right past it.
All right, what happened? So we have.
Let's debug our math. So.
Well, let's write in here. Let's put a console log.
So log within X. That should at least log. So it's not logging right now, and it should, right? Because when we're even here.
Yeah, it should be logging for that. So if it's not, there's something wrong with this. So we call it bounce paddle. We didn't do anything weird bounce paddle is spelled correctly there. Mm-hmm. And it's saved on your end, right?
Yep.
All right. It's not saved on mine, but that's probably the weird sharing of things. Okay, so this location at X, that's the middle of the ball, plus the radius, so that's the right-hand side, if that is greater than this dot petal to x.
Well, we don't want the right hand side.
Aha!
You
know what the problem is? This dot petal dot location dot x.
Yeah, good call.
The problem there is that JavaScript is being way too nice to us. Even though it doesn't exist, it's undefined. And then it's like, well, clearly the not a number is false, so there you go. It's false.
Location. Okay. Oh.
We're too close.
Yeah, so like right out the beginning. So we don't want to do greater than or equal to, I think. We just want to do less
well,
than.
there's actually one more thing that we can do.
Okay.
When we set this dot velocity dot y, let's also raise it above. Like, let's reset its location too.
This dot location dot y plus equal to.
We can't actually know exactly where the paddle, like how far it got inside the paddle. So let's set it relative where the paddle's y.
So this dot paddle.
Well, no. So we don't want to set the paddle's location. This dot location dot y.
Plus equals this dot paddle.
Let's just say equals to this dot paddle dot location dot y minus this dot radius minus like 1 or 2 or 3.
So that's gonna make sure that it hits above. Whoa.
I saw some errors.
I didn't say paddle.
And is there a dot that needs to be in there? Oh, there is. Okay, your cursor is blocking it.
Okay.
Did something else happen?
Yeah. Look, it immediately goes down. So like when the page loads, paddle boom goes down.
That's fun.
So if this dot location dot y.
Let's not just set it. Well, okay. So it's checking to see if it hits there. The radius. I'm sort of curious now. Let's go take a look at radius and see whether or not it is what we think it is. Is it a radius or is it a diameter?
Oh. Let's see.
Let's look at the documentation.
For ellipse.
Because that will kind of change things.
No, I need to go to reference. Oh, sorry. Ellipse. It is just width and height. Yeah, so that's that's why. So we need to do. So let's do this. Let's say let's.
Well, that size is nice. Like we like that size.
Yeah. So let's do this dot width is radius times 2, and we'll set the radius to be 15.
Okay, so then we can say like the width or the height.
And then now where we actually want. The
I actually
height,
want to say this dot size.
Okay, because it's
I mean,
circle.
the height should be the same.
But then the only place we need to change that is in when we draw it, right?
When we display it, yeah.
And yes, because every other time we thought it was the radius. It's just going down.
Now it's still going down, but I think that's because it's initializing right on that, like right on top of the paddle.
Mm-hmm.
We need to raise it above the paddle slightly. So when we initialize the location, let's make sure it's minus a few more pixels.
Minus 5.
Yeah, it'll be like, nice little...
Oh, do you see it? It's starting right on top of it, though.
Oh, wait, you know what? Look, we're doing this dot radius divided by 2. We now need to change that for our initial location.
So this needs to be this dot size divided by
This
2?
dot radius.
Just the radius, not divided by 2?
Right, because now, yeah.
We're doing so many things. Okay. It's just going down. Actually, can we do
We could not also make it, let's not have it move.
Yeah, let's not do a draw, right?
Let's not update it.
Don't update the ball or bounce. Just to see where it starts. Okay. So it's floating.
It is floating.
It's floating above the paddle right now.
Its velocity initially is somewhere going upwards.
Okay, so if we look at it, velocity a negative y velocity should send it up, right?
Right.
Okay. And then when we attempt to bounce off of the paddle, we are saying if our x location plus the radius, so that'll give us the right-hand side of the ball.
Right.
If that is greater than or equal to the x location of the paddle, which is the far left of the paddle,
The top left, so that
Okay.
left line.
and the x location minus the radius, which will be the left edge,
Right.
if that's less than or equal to the x location of the paddle plus the paddle width, because that'll be the far right of the
Right.
paddle.
That's the far right.
That's an x hit. Cool. If this dot location dot y plus the radius, so that would be the bottom of the paddle.
That's the bottom of the ball.
Or is it minus radius?
So, because x and y starts at the top left of the entire screen,
Mhm.
If we add to it, it goes farther down the screen.
Okay.
So that plus does mean it's the bottom of the ball.
Okay. And then if that is less than...
Greater than. We want it to be greater than.
Right, because it's the bottom of the screen. Okay.
Great. This is like my dyslexic tendencies kicking in.
Okay, so now, and let's not even try to update like that y there. We should just be able to set negative velocity. Bounce edges. Bounce
Well,
paddle.
that updated location, so it's really useful because we're moving faster than 1 pixel per
1 pixel per second.
per second or per frame.
It seems to be working though. Like check this out. Like
Every once in a while,
it'll hit.
like that.
What is
What happens is, so it's moving really fast, right? And it instead of like actually just moving 1 frame at a time, it's moving X pixels per frame. So there is a chance that it will actually move and be multiple pixels inside of the paddle. Right now we have it reversed, but the next frame it'll check again. It has reversed, but it's still inside of the paddle. It will do a second reverse, and it'll do that little
okay.
thing like that.
So what you're saying is we should change the location to be a little bit above the paddle.
A little bit above the paddle.
So
That should be good enough.
subtract the radius and subtract 1. Okay.
And that should guarantee us not to run into those problems.
Okay.
Now, if you try to get that side on, it won't work. Now, I do see one problem that we have. We don't have something in our to-do list to fix it, but we can move our paddle off the sides.
Oh, that's true. Let's fix that real quick.
Yeah.
So paddle should stop moving when it hits the right-hand side.
Right.
You can go ahead and code this. So we probably need another function in the paddle called like
maybe
or just
we do have move here.
Yeah, so we should
we can set this where we don't allow it to move if we're already to the right edge. Or what I might do is allow it to move and then cancel the move. So we will say if our new location, so this dot location dot x, if that is now less than 0, we now want to just set this dot location dot x equals to 0. So we just canceled it out.
right.
Else if this dot location dot x plus this dot width, if that is greater than the width, hey,
Not
VS
this,
Code is trying to.
not this dot. There you go.
Okay, so if we're greater than a width, we want to also say this dot location dot x is going to be width. I'll take it. Width minus this dot width.
Because the width will be the edge of the screen, and then this dot width will be the width of the paddle, and the location of their paddle is the top left of the paddle.
Exactly.
Okay, let's see. So now, can't move past that, and we'll do that, and we can't move past that.
Perfect.
Sweet. All right, I think we need some bricks now.
Bricks might be nice.
All right, let's look at our to-do list. So we're bouncing the ball off the paddle. That's great. Let's create a row of bricks. I think I'll get us started. So let's create a brick class, brick.js.
And Jason says, because you start going up and are close to the paddle, it goes down. So yeah, that was a comment during when we had that the weirdness with the ball just immediately going back down again. It was because we had that impact right away,
right.
And we were, it's fun. This is what we run into when making games all the time.
We're about to start coding the brick. In the chat, if you have some suggestions for brick colors, say them out. We'll choose like a random color for every brick or something like that. Let's take a quick stretch too. And send us the RGB of the colors that you want.
Can you copy paste there or?
Yeah, I can pull them in.
Oh right, because you have that cool.
Yeah. Okay, so we want a brick. What does the brick need? It needs a width, a location.
So are we? You got a file for me.
Yeah,
okay, so yeah, we need a location. We need a width, and we need a height. We need a color. We need probably something easy. Like if we're gonna have a score, we need the brick can keep track of how many points it's worth.
This dot points 1 for now.
Yeah.
So I'm saying the width is 50. That's like half the width
of the paddle.
Oh,
so
wait. Yeah, well, less than half the width of the paddle.
I actually foresee a potential problem with this. We don't know how many bricks we want.
So
do we want to fill the entire screen with that?
Yeah, we'll pass in the width.
Yeah. And let's pass in the location instead of X and Y.
So we're actually going to pass in a vector?
Yeah.
Okay. And anything else?
Okay, so we need a height.
We'll also pass that in too, right? Or I guess we can default.
I mean, they could be default. They could all be the same height, and they're all going to be the same height, maybe.
Let's pass it in, because then we can make the bricks thicker or smaller. Cool. And then in display, we want to fill with the color, and let's actually pass in the color too.
Right, because if we want them to be random.
Yeah. This stuff.
Now we could do something interesting, like we pass in like a difficulty or like a point value, and then it chooses what type of color it is based upon that.
Let's just do it random, right?
But for right now,
because right now everything's going to be 1 point.
Right.
Cassandra didn't. She sent color names, but not RGB. So I'm gonna go with Paradise Blood. He's saying, well, actually, in a second when we generate the bricks, we'll use those RGBs. But we'll fill with this dot color, and then how do you create a rect? Does it create rect?
It's just rect.
Rect. With a width and
X and a Y.
X and a Y.
X, Y. Yep, and you actually got that on your preview window there.
X, this dot location dot Y, and then a width. Oh yeah, it is telling me width, and height. Cool. So we got a brick. Now we want to create a bunch of bricks.
Well, let's.
What else do we need?
For right now, let's just create one brick.
Okay.
And get it onto the screen.
Cool. So I guess you can do that. Try to do that in setup.
So yeah, I'm gonna start with this dot, that brick, and do brick equals. While you're doing this, we also can't forget to bring that file into the index.html.
Yeah, I'll do that after this.
So brick equals new brick. We're bringing in, and this is so good about VS Code. I can see this, unfortunately you can't see, but it's telling me location any. So for right now, I'm just going to do a create vector. I'm going to put in just 0, 0, so top left. Mm-hmm. What else do we want? So width, I'm going to say, for right now, we want to have like a certain number of these. So let's say const number of bricks per row. How many do we want?
10.
10. So we have a fixed size, so const brick size or brick width.
Brick width, yeah.
will be the width divided by number of bricks per row. So now we can pass this in to brick width. The height, let's just say 25 for right now. I don't know. And then color any. So the first color here.
Go from Paradise Blood. 265, 165, 0. Is this the color of blood? I think it's not. I don't know. We'll see.
Okay, so this creates our brick.
So
and then down here,
yeah,
we're just going to brick.display.
Cool. All right, we got ourselves an orange brick.
Yeah.
Nice color.
Yeah, that's a really super... And our score is updated to orange, too.
Yeah, we haven't set the fill of the score.
All right, CJ, we don't have to play the game right now.
Okay, so we got the brick. Should we create the logic to break it, and then, or should we create multiple bricks?
I'm thinking let's just create the entire row of bricks right now.
Cool. I am going to rename your variable to bricks per row, just so it fits on the screen easier. But same thing in mind.
I hate you forever for
it. Okay,
no,
cool.
It's fine.
So we have bricks per row, and then basically we want a for loop to create that many bricks, right?
Yes.
Yeah, so bricks per row is there, and brick width is there.
Also, I think that we should change brick to bricks and instantiate this to be an empty array.
Okay. And so then we'll do for let I equal 0, while I is less than bricks per row, I plus plus, and we're going to create a brick. It's going to be at brick width.
Well, so everything stays the same except for our initial create vector for the x and y, the location.
Okay.
The y will stay the same, but the x needs to be...
brick width times I.
Yeah, exactly.
And yeah, then everything else is the same, and then we'll push the brick into the bricks array. So bricks.push the brick, and then now we'll iterate over them to display them.
And I was thinking we can just use a for each for that.
Cool. Bricks.for each brick brick.display. Go down. Like that.
All right, we should get an entire row of bricks.
Hey, we got a row of bricks.
So if we had we have a few more colors. We can make these randomized colors.
Let's do it. Okay, so Adam's saying Jason's already looking for that high school. That's like an inside joke. Leanne just tuned in.
Yeah.
Hey, Leanne, welcome.
Welcome to the stream.
Welcome, Jason. Okay, so let's do like an array of colors.
Yeah, an array of possible colors, and we can randomly choose one.
And I think I'm gonna have to create this in setup because we don't have access to the color function until setup.
Plus, we don't need those. We don't even need the colors array outside of setup, so we can just create it inside of.
Okay. So we've got a paddle and a ball. We're creating a canvas. Let's just do it here. So we've got our array of colors, and then let's say colors dot push. We'll say we want this color. This is the orangish color. And then colors dot push. Another color in the chat is from Jason Michael for 135, 206, 250. Were there any others?
We're running out of color choices now. Cassandra, just how about medium purple? We can do that one.
Can I put the string in there? Can I figure that out, or do
no. She gave one earlier. 147.
Oh, like the same color as the ball.
Yeah.
Okay, that's fine.
147, 112, 219.
Cool. And then we just need to pick a random color. There's like a random function built in, isn't there?
So there is a random function built in.
Okay.
We can just do that as colors.push. Oh, I thought you meant like another random color on top of that.
No, so we have to. I want to grab a random color out of the array.
Right. So.
Can I have a min and a max?
We can. Let's actually, because I always forget if it's inclusive or exclusive for the max.
Okay.
Let's just try that and see if we get any errors.
Broken. Object arguments is not a valid color representation. Colors does have each color in it. It might be exclusive. Oh, well, no.
I couldn't read that error message fully.
I need this to be a whole number.
Oh, a whole number. So
Yeah.
we need to math.floor it.
Okay. Is there anything built in to do that?
That probably is.
So math.floor of random. Does random accept a beginning and an end?
Yeah, random accepts a beginning and end, or it assumes 0 if you only put an end.
Okay.
What was that error?
And then I need a parenthesis at the end to fill it off. Okay, cool. So we got like a light blue, but we're missing purple. So I think it's exclusive. Yeah, there's some purples in there.
There we go.
Cool. That was weird.
What was weird?
It hit like the edge.
Oh,
yeah,
right.
like that.
Well, because we have it set where if it hits any part of the paddle, it bounces up.
Cool.
We got another color here.
I like that color a lot. 42, 42, 42.
P5. Oh, so there is a just pure floor function.
Let's
right.
use that.
You're right, William.
Okay, so we'll say floor. Ooh, it's like a dark black. That's cool. All right, let's get these these bricks breaking. And actually, we should draw the score afterwards, so that way it like always shows up on the screen, right?
Right, we could just move that to the very bottom. Which will be very interesting because now that will make the text the exact same color of the last brick that we draw.
Let's just make it white. And I think we need to fill before we draw the text. I think that's what
Correct,
the issue
yeah.
is. Okay, cool. All right, so do you want to try this? We need some sort of
Collision detection.
Collision detection.
Yes.
For the break. Yeah.
Okay, so we have to decide where to start doing that. Like
Yeah.
in draw here, we could say like right now we have ball.update, the key down, bounce paddle. We could, who do we want in charge of this? The bricks or the ball? Probably the ball.
Well, if it's the ball, then it's gonna have to iterate over every single brick, right?
We're gonna have to do that anyways.
Well, we won't though because because we'll have to call the brick.
We have to call each brick to call the function to see if it's bouncing off of them.
I say we do it inside of the brick, because I don't want to ask the ball 10 times. I would just want to ask each brick one time.
Okay.
It is the same number of calls, but it's like, oh yeah, and we could do it there too.
So what I'm thinking is
Yeah.
here, like in our for each loop that we already have.
Whoa, what just happened? Yeah, so that way we only have one iteration of the bricks, and then we can say...
Right, so we're displaying the brick, but we also want to then say brick.check collision, or
Yeah.
collide with ball. And we just pass in a ball. So we're done. It works, right?
should we call this just collide? Or do you like collide with?
I'm very verbose with my variable names usually.
Cool.
So
Collide with the ball. Cool.
So
now we need
brick
that.
collide with the ball. Do we want the brick to tell the ball to change directions too?
Yeah, because then we can. The ball does have a update. Well, no,
It's sort of doing that. We don't have a method on there right now for that.
I thought we had like go in the opposite direction. Ball.
We do, but they're being manually done inside of the ball.
That's what I'm saying.
There's no method for it yet.
Oh, okay.
We could create one.
I think we should. So I think here's what will happen. The brick will have its collide function. If it detects that the ball has collided with it, it will say like ball dot like collided or whatever. So that way that'll make the Y go in the opposite direction.
Got it.
Yeah, okay. So go ahead and you can do the collide, and then maybe I'll do the one for the ball.
Okay, so brick.collide, let's head over to brick then. So we need a collide here. And we're getting a ball.
Yep.
Okay, so we need to do exactly the same thing we did with that paddle. we need to check if like the x and the x and the y of the ball is within
It'll be
each of the
reversed,
petals. But
right?
it's well, let's just see if it is. So it's going to be if ball dot. Well, let's just do from the brick's perspective.
Mm-hmm.
So this dot location dot, and something that's interesting is that each brick is looking from the top left of the rectangle. So if, and I'm going to be referencing my nice little brick thing that was a paddle before, but now it's magically a brick. So if the top left, I kind of want to do this from the ball's perspective first. So I'm just going to say if ball dot location dot x. So the left-hand side, but we want the right hand of that. But do we care about that, or do you just want to do top and bottom?
Just top and bottom.
Just top and bottom.
Oh well, no, because if we do, because you might have seen a game before where there's like space around the bricks,
Mm-hmm.
and then it can like hit sideways or it can hit from the top.
So that's going to be, well, that would be top and bottom though.
Yeah.
With left and right, do we care about that?
Oh yeah, that's what I'm saying too, because it could be, if it bounces off the side and then hits the side of a brick, it should break.
Okay. So let's do if the right-hand side, or we could just do if the top. So if the ball location dot y minus ball dot radius. So if that is less than or equal to this dot location dot y plus, because we need the bottom of that brick because we're checking the bottom of it,
Mm-hmm.
plus this dot height. So if we do that, now we have one potential collide now on the y-axis.
Right.
But we also need to do an and here too.
Check for the x.
So, well, that's just the bottom row side.
Mm-hmm.
Yeah, we need to check the x too. So if ball.location.x, well, we did do this twice, right? Because like the left-hand side and the right-hand side.
Mm-hmm.
So the minus first for the left-hand side? No,
Well,
plus.
because it's...
Plus for the right-hand side.
For the right-hand side, plus, yeah, because the x is the left of the ball.
So ball.radius, if that's going to be greater than or equal to this dot location dot x and ball dot location dot x plus minus ball dot radius, if that is less than or equal to this dot location dot x plus this dot width.
Okay, so this first one checks y. That's good to go. This next one says, is the ball's x to the right of the brick? And then this one's going to say, is this to the left of the brick?
Of the right-hand edge. So like right of the left edge, left of the right edge.
Okay. David is saying, what? No width? We are checking against the brick width. Can you clarify? Not quite sure what you're asking. But this should do it. This says that we have just collided with a brick, right?
Right.
Okay. So then we should say like...
well, we've collided with the bottom side of a brick.
Okay.
We haven't checked the top side of a brick.
Okay, but we'll still.
We could actually add that in as another ampersand if necessary.
Yeah. So this is collide with bottom. Let's just have this as...
I almost feel like we could just add this ampersand right easily in there.
Well, here's the thing though. So when it collides off of the... Wait. When it collides off of the bottom, the y needs to increase. Y velocity of the ball.
It just needs to reverse.
Right.
Whatever we do, it reverses.
But if it hits the top...
It's going down. So
it still reverses? Okay.
It still reverses.
Okay.
So we can just say that this is another ampersand. And we need to do the opposite of what we did with the that first y. I kind of want to put those together. So we can say if ball.location.y plus ball.radius, if that is greater than or equal to this.location.y, now we're going to be checking. Are you hitting the top or are you hitting the bottom?
Less than for this one.
Let's think about that for a second. Okay, so because y goes down as we further go down, if it's greater than, we're checking from the bottom going down into it. And if it's less than, we're checking from the top going up into it.
Okay. So if the location of the ball is greater than the y location, meaning the ball is below it.
Right.
But we want to check if it is right on top of it.
Well, it's rarely going to be the exact pixel perfect line. So we want to see if the ball has crossed into it.
Okay. So if it's crossed into it and we're on the same x, but these x's are checking the bottom of the brick, right?
They're checking the left and a right.
So now we need to check the...
And we have that with the top two lines with the y's.
So now we're checking all sides of the brick?
We're checking all sides of the brick.
Okay. So we have collided with the brick.
So this pattern has a name. It's the bounding box. The bounding box pattern. This is the type of thing that unfortunately is really like sort of hard to wrap your brain around, but it's also no reason to go and like get yourself a huge library or framework like Unity only for bounding box collision.
Basically, we're checking to see is the ball potentially within the brick, and the bounding box is the brick itself.
Right.
Okay. So we have collided with the brick. Now we want to say like ball dot.
Where? Okay. It didn't show up on my screen for a second.
So we've collided. Now we want to tell the ball to like reverse.
Right.
But we either want to reverse its y or reverse its x depending on which way it hit, right?
Right. So for right now, let's just pretend that we're only going to hit from the top or the bottom.
Okay. So we'll say ball dot reverse y.
Yeah, let's do reverse y.
Cool. And now we have to make this thing disappear. So
actually, you know what? I've changed my mind. Let's not have the collide do anything to the ball. Let's return true.
Okay.
And I would like to rename this is colliding.
Cool. Does collide. is collide because it's happening right now. So if the ball is colliding with the brick, we'll return true. And that way we can just pop it out of the array, right?
Right, exactly.
Yeah.
Well, actually, again, I think we're going to have a little bit of trouble with that.
Why?
I think because we're doing a for each.
We'll do a for loop that goes in reverse.
Yeah, we need to do a for loop in reverse.
Okay, that's fine.
I know. I love using for each or other, the functional functions off of arrays, but it's not always the best decision.
While I is greater than or equal to 0, I minus, and then we want to do these two things.
Don't you want greater than or equal to 0?
Yes. What did I call it? Brick dot. So if brick dot is colliding with the ball, then we'll just splice it out. But then we'll also reverse the ball.
Right. So we want to tell the ball to reverse.
Reverse y.
And then we also want to remove the ball, remove the brick from the bricks array.
That splice should do that.
Yep.
Okay, so if the brick is colliding, we'll reverse y. So now we need a reverse y in our ball. Do we have an update location? No, we just have bounce. We have bounce edge and bounce paddle. Do we want bounce? No, we'll just do reverse y. We've already
just reverse y.
Yeah, because if we had bounce brick, then that would probably do the collision, all of the collision detection inside of there.
Yes.
Okay. So this dot, do we have a velocity? Yeah, this dot velocity dot y times equal -1.
Right, and now that I think about this, we're doing this twice. In the bounce petal here, we have this, and oh, it won't let me auto select. Let me see if I can find this.
Which file are you in?
On ball.
Okay.
I want to see if I can.
Oh, so yeah, so all these other places you just want to call this dot reverse y.
Exactly.
Yeah.
So I want to for these. Let me see if I can to be tricksy with my. Close.
Want me to do it for you, Brooks?
No, there. This dot reverse.
No, because you
Hold on.
You also selected reverse x.
Well,
Undo.
We're about to change that too.
Okay.
So, and I should be able to do this. Can I change the caps? Can I? Oh, I can't capitalize. Okay. My entire thing ended right here. I can't.
Here, I'll. Oh god.
You undid all my work.
Yeah. But I actually didn't. So oh my goodness, this is weird.
All right, hold on.
Undo what you did.
Oh, that is.
Okay, but
I think it needs a little bit more work with like it's super close, but
yeah, I see what you were doing that. So actually, I mean, I really just want to replace these two with this dot reverse.
Right.
Reverse
but
y.
I want to also do the same thing.
And then we'll do
where,
these as this dot reverse.
I just
x.
had another crazy idea.
What?
Instead of reverse y, we just like reverse and then pass it in like the string x or y, and then.
Because then we don't have to write two methods. Okay.
Right.
Okay, reverse, and then we're gonna pass in. What should we call this?
That would be the coordinate x or y. It's the Cartesian
I'll call
point.
it the coordinate. Yeah, and so then now all of these reverse y's can just be reverse where we pass in the letter y.
Right.
And then these will be reverse where we pass in the letter x.
Exactly. Oh, and down here on line 42, we need to make sure that we actually do.
Coord times equal -1.
Yes.
Okay.
I think we've got that.
So if the brick is colliding, reverse the ball.
We haven't actually tested all of that. We just did other factoring at the same time.
This reverse is not a function. It's now no longer reverse y. It's reverse with that. Oh, where did all our bricks go, though?
Did we break them? Are there any errors? Are we not displaying them?
What is... Oh, I spelled reverse wrong inside of the ball. Yeah. Because it's bouncing the edge. There you go. But the bricks aren't showing up anymore.
Yay! Okay, so let's think about this. So we're going in reverse.
Oh, it broke a brick, though.
It broke a brick?
Yeah, but let's make sure our for loop is good.
Okay, so for let bricks equals length minus 1.
Oh, brick is not a variable anymore. Brick's at i.display.
Yep.
And
actually, you know
let's
what
just
might be easier to do?
Store in a variable.
Yeah, store that like const brick equals.
Bricks at I. Cool. I wonder why I didn't even say brick.display is not a function.
Yeah, that's a good question.
It's working. All right, Brooks. Oh, we hit two bricks at one time.
So if it hits the edge, it's going to reverse, but then it's going to immediately hit the other edge,
right,
and then reverse again. Now the reason it's doing that is because we're not repositioning the ball when it hits. But actually, that takes a little bit longer to do because like we have to calculate: did we hit it to the left? And we have to there's tons to do. But we have a game. We have a game.
So let's create multiple rows now. Then.
But hold on.
What?
We're killing bricks. We in our last moment of the brick before we destroy it, let's increment our score.
Oh, true. So if the brick is colliding, then we'll say player score plus.
Plus equals the brick dot value or score or whatever we put that in. Because then, in our stretch, if we end up having harder to destroy bricks.
Did we give it, I think, points? Let's look at the brick. Yeah, points. Score 1. Hey! 3. Sweet. So now let's make like 5 rows of bricks. And then we could even do it where like the sides of the bricks are empty. So that we could go on top of them. I don't know.
I mean, there's so many different things that we could do at this point in time. And I think for a lot of it, we'll just leave that as an exercise for any viewers, or if we want to do that in the future.
Yeah. Okay. There we go. Do we still lose? Yeah. So one thing we need is, okay, I think we have it in our...
we do have game is over when all the bricks are dropped, and the game is over when the ball is dropped.
So we created 1 row of bricks. The ball bounces off the brick is destroyed, the score increases by 1. Game is over when all bricks are destroyed. We haven't done that. We haven't done game is over when ball is dropped. Before we do either of those things, let's create like 5 rows of bricks.
Yeah, let's do that.
I want some bricks to break. Okay. So in here, we'll create a new variable, rows. Set that to like 5. And then we'll do a for loop that goes from 0.
So we have a lot of these now. Like a lot of the stuff in the setup that's just about creating the bricks. I'm thinking we can just put this into another function.
Like all this brick stuff right here?
Yeah, and then it just returns an array of bricks.
Okay. Yeah, definitely. And we'll just say like bricks equals that array.
Yeah, bricks equals that function. Yeah.
Let's write it out before we do it though. So now that we have number of rows, the y is going to be... do bricks have heights? We pass it in the height.
They do have a height.
And it's 25 because we're doing so it's going to be 25 times the row will be the y.
Right.
Look at that. But we're saying we should take all of this, put it in and say like bricks equal create bricks.
Which means down here at the top, just to make it a little bit easier, I'm just going to say let bricks.
Okay. Were we using anything in there? So we're taking in... We are using colors.
Colors is native to...
But we're using the colors array to get the random color?
That is true. We can pass in the colors array.
I guess that's true. Did we get any more colors in the chat?
Good question. Nope, we have not got any more colors in the chat.
Okay, so, and then we actually, we just want to create, in here we create a bricks array and then return it.
Yep, exactly.
Why is this tab like that? Bricks is an array, we'll push into bricks and then we'll return bricks. Cool.
Yep, and now setup is a little bit cleaner.
Yeah. That just destroyed 3 bricks in one go.
Well, it gets really interesting when you hit an edge and it goes like deep inside, and then like sort of you get this ping-ponging back and forth. But like there's so many different things you can do, like powers that you can create. From this angle, looking at your screen that's playing it, some of the darker colors are like black to me.
Yeah,
so.
it's really hard to see the blacker ones. That's the 42 color one. Someone please give us one more color.
We could just create a pure random color.
How do you do that?
We'll just use random.
Random.
Oh well, that's one we already have in there.
Well, 42 that's the black one. I'm gonna get rid of that one.
Oh, okay.
Between 0 and 255.
Yeah.
Is there a random color function?
I don't think there's a random color function.
Ooh. 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 Let's do that like 10 times or something.
Well, at this point in time, if we're gonna do it 10 times.
Put another function.
Maybe we should create another function called generate colors.
So I'm gonna do this. It'll be totally fine, and then we'll do like the game end states, and I think we'll call it there because we've been streaming almost 2 hours now.
Yeah.
So that'll be good. But yeah, I want like 10 random colors in here. Plus. Oh no. Do this. And yeah, that should do it. Now we get a bunch of random colors. Ooh, that's pretty.
And we could do all sorts of crazy things like changing the size of the bricks, changing, like having different rows be different sizes. There's all sorts of ways to customize the game, so it can be really interesting and like unique to whoever's coding it.
Cool. Okay.
William says floor random 255. I believe that.
Because that will be the maximum.
Oh,
right. Because we need whole numbers.
You don't need to floor it because P5 is smart enough to actually just figure out
For the RGB values.
Yeah, for the RGB values.
Yeah. I mean, that's what I wanted to see. Like when it went on top of a brick, it was like doo 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 doo.
Yep, that's when it gets nice. But
Okay.
what I want to say is, game is over when all the bricks are destroyed.
I'm gonna create a function. Create colors. Okay, now we're a little modular, but I'll let you code this up. So we want to do game is over when all bricks are destroyed.
Right, so, which lets us know we need some kind of state. So maybe something like let game being played, let playing is playing, game on, well...
Game on!
Let playing.
Sure.
And we're going to initialize this to true.
Right, because the game is happening.
Right. So playing equals true. So we are playing the game. Then if at any time we no longer have any bricks. So we can find that out if... Where are we? Down here in draw.
Mm-hmm.
Right when we're looping through here. In this section, when we kill the brick, if there are no more bricks after this, so at the end of our for loop, if what is it,
bricks.length.
dot length. Now I know that I could just do if not bricks.length because 0 is falsy.
Mm-hmm.
I don't actually like to use that because it's sort of hard to read.
You can be explicit, yeah.
I'm going to just say if this now is 0. If we have no more bricks left, we have reached the end of the game, which means we can say, what do we call it? Plain?
Yeah, plain.
Plain is now going to be false. And maybe we can display, like, game over.
Yeah, let's do it.
At the time. Which, well, we kind of did that already. I could just put this right in here. What do? We have text. I'm just going to copy this text. And probably the fill too. So fill 255, and we have the text, which is score. Well,
really, we just want to say game over.
We just want to say game over, don't we?
Yeah. And the X and Y location. I guess we can put it at the middle of the screen.
Actually,
use single quotes.
You win.
Oh yeah, because it's not game over.
Okay, so we're gonna use single quotes, and then we want this. So we have width divided by 2, height divided by 2, right in the center. Now...
Yeah, is it the top left of the text or the center of the text?
It's going to be the top left of the text, I believe.
Okay, let's just...
And you know what? It's going to be really easy for us to do this, which is I am going to not have... Where is our...
Playing true?
We're creating the bricks right here. Create
Yeah.
bricks. I'm just going to say... bricks equals an empty array. So this should initialize us in a game over state.
Yeah.
Yeah, it's a little bit there. We could like figure things out via code.
So, here, I want the text size to be really big, like 100. You win. Okay. And then width divided by 2 minus like 400 or something like that. That's too much. Half of that. That's decent.
It's okay.
Yeah, we'll do 220. You win!
Close enough.
Yeah, definitely close enough. Okay.
And we're going to want the same thing for you lose. So right now we have somewhere in here ball dot.
We're doing bounce edge and bounce paddle inside of draw.
But we're not. What we're not doing is ball off bottom.
Right, and I think we should check that like right after bounce paddle.
It's easy for me to forget that your cursor is not mine. Okay, so if ball dot off bottom.
Yeah, off bottom, below bottom, off
below
screen,
bottom.
off screen. I don't know.
Off screen is good. I think below bottom, because we're only going to be checking if it's below the bottom.
Okay.
So if the ball is below bottom, then we want to initially just set plain as equal to false to make sure that we're done, and then we can just display the same text. So
let's do that.
Come down here, get this.
We do want to do the text size too. Yeah.
Yep. You put them far apart, so I have another plain equals false. I'll just delete this one. And this one, let's just say...
Make it you lose with 2 exclamation marks, because then the math might work out the same.
Also, I'm thinking instead of fill, we're going to do something like red or...
Yeah.
255, 0, 0. Okay. And we can now create the bricks again.
But also, so playing false... are we checking that anywhere else?
We're not really checking anywhere else. We probably don't need to play.
I think we need to move everything into like an if statement. Like if playing, then do the update and do the everything, right? Because right now, like...
Yeah, but we'd also need to keep track of the state of what type of playing we have. Like, is it because there's no more... Well, okay, okay, so here's how we could do it. We can do that. So we're going to get rid of this.
Before we do that, though, let's implement below bottom.
Yeah, we could do that.
So in ball, we need below bottom. Where are you going to put it?
Right here.
The bottom? Okay.
Below bottom. Okay, so below bottom, we're just going to check to see if we're below the bottom of the screen. So if it is return this dot location dot y plus
radius.
I want the bottom. I want it to fully go off the bottom. So it's really going to be minus, because I want the top of the ball once it goes below the screen. So minus this dot radius, if that is greater than height.
Right. Then we are below the bottom.
Then we are below the bottom, and returning a boolean because of that greater than symbol. So I've implemented it.
Cool. Sunil says, your channel is great, very helpful. Keep up the good work. Thanks, Sunil. And Sanjay, welcome to the stream. We're getting pretty close to the end. Like let's show the game real quick. Yeah, we have like a basic brick breaker. We can do this. Right now we're just setting up in states, so we can say like, actually let's test what Brooks just did. Yeah, you lose. But you'll notice it is starting over. So this is what we're gonna fix now.
Right.
Is just like actually in the game, so it doesn't. Or maybe we'll have like a button to restart the game or something.
Or like we could just make you refresh because we're mean like that.
Okay.
Okay, so if we have plain equals false, we start with plain equals true, and we hit this. All we have to do now at this point in time is just say plain. I'm gonna copy that and just say plain equals false. And down here, when all of the bricks are gone, bricks.length, this also will be plain equals false, but with nothing else in here.
Wait. Let me know where you're going with this.
Because now I'm going to have if plain.
Redo what you just did then. Because here's what I'm thinking.
Wait. Mine is going crazy now too.
Oh my goodness!
I'm not touching the keyboard.
I just pressed Control Z. Try again.
I did Control Z too. Oh wow, that's like very weird.
Oh. Dang it. Okay, we're gonna have to write that again. But here's what I'm thinking though. Like we need just like one if statement. Like if playing, then we handle moving, we handle displaying, we handle all this other stuff. And we even check for like bricks.length. Honestly, we could just wrap this entire thing in an if statement, right?
Yeah.
Okay. But We need to get back the code that you wrote. Well, what was your thought with moving the drawing of the text though?
Oh, well, that was going to be, we can just basically say if we're not playing, we can just check right there the state of like whether or not there's any bricks. If there are bricks, we've clearly won, and if there's not bricks, we've probably lost.
Oh, okay.
I mean, sorry. If there are bricks, we've lost. If there are not bricks, we've won.
Right. Okay. But then, yeah, I guess that would mean we're writing the text every single time.
Writing the text every single time.
Well, like because we're doing text and fill inside of the draw function.
Well, we're already doing that right now.
Okay. Cool.
And we do need to do it because it clears off. It like clears the.
Clears the screen every time.
We want to make sure that it's, that it actually stays there, not just one frame.
I see what you mean. That's why we're doing that. Okay, I'm gonna put back what you had so that we can finish that thought because it went away when we
Life
tried
update is good. It's lasted several hours here, but it clearly
2, 5,
it's
0.
I would be so pissed if we had spent like multiple hours and then everything erased itself in front of us.
Yes. Brett says awesome stream. Thanks, Brett. And Paradise says great stream. Learned a lot. Awesome. That's what we're here for. Okay, Brooks. Finish your thought and make this thing work.
We want to. So as you were saying, we want to wrap this entire into a plane. So we can do that here. Okay. If plane, then we come all the way down to the bottom. Am I in another function? No. That's not my cursor. That's your cursor. And we're going to grab this and tab you up. Okay, so save.
If we're playing, do the thing.
If we're playing, we do all these things. Okay. But we're going to have, if the ball is below the bottom, playing equals false. So I'm just going to put that right here.
Okay, so simply playing equals false.
Playing equals false. So that's one way to get out of here.
Right.
And the other way to get out here is if the bricks.length is equal to 0, then we also want to set playing equals false.
And we're going to move like the drawing of whether you win or not into
playing equals false. Now, if we are not playing, we now have just an else.
Okay.
So else, well, we're not playing anymore. Now we can just say, okay, text size is 100. Is that tabbed properly? It's hard to tell. It looks like it is. These are not.
Yeah, well, that one's not. Yeah, do that.
Okay, so we don't need to set plain equals false anymore.
Actually, I mean, should we set... could we just have a variable that's like win or lose? True or false?
We could do win or lose and just set those, too.
Let's do that, because that way... then we just have, like, if win, we display the text. If lose, we display the other text.
We can have, like, let...
Where are you at?
I'm trying to think of, like, one to do with an object, but we could just make it simple, like, let win equals...
well, I guess that's the thing. If we initialize it to false and playing is false, then that means they lost.
How about game state?
Sure. And so game state has, like, playing and win or lose.
Right, so... Plain, instead of plain, it's now going to be game state. Game state is going to be plain, and down here.
I see.
See where I'm going with this?
Sure.
If game state dot plain, game state equals plain.
Mm-hmm.
All right, so now we're plain. But if we're not, this is going to be game state is now going to be equal lost, lose. And down here, where's our...
75.
75, there it is. This is going to be game state equals win. Now, down here, we can now just do if statements. We know that it's going to be text size equals 100 no matter what.
We just do a template.
Exactly.
Game state. And then let's capitalize win or lose. Win and lose. Okay. And did we comment out? Okay, I think that's it. Outer property length of undefined. Brick breaker line 64.
We could even say
Oh. Are we setting bricks right now?
bricks should still be there.
Somehow they got the variable name got messed up. I have to. Okay, there we go.
In all of that like auto erasing that VS Code did for us.
Yeah. Seems to be working. All right, I'm gonna win this game. Actually, let's see if I can lose. You lose, and nothing happens. I can't move. It's good. Do we want to set it red?
We wanted to set it red,
Okay.
which is unfortunately that's going to be a little bit. I'm not sure the easiest way to do that. Besides,
That?
well, but then we'd want it white when you win.
Oh, I just made it. Oh, that's 0 255. So we'll say game state equals lose, then fill, else fill with white. Yeah.
We're setting game state equal to that.
No, I mean, but I guess regardless if we are if game state is equal to lose, then call fill.
Oh, okay,
Otherwise
right.
Call fill.
Yeah,
Oh, that was pink. Oh well. So
close enough.
you lose. All right, now I'll try to win. Doo 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 doo. Here we go. Ooh. Ugh. No. Oh, almost lost. I feel like we almost need to implement lives just so.
Just so that you could possibly
guess,
win.
Yeah, I guess I could do like one row of bricks or just like one brick. Ooh, that was a legit one. Pew.
Oops, I accidentally saved it. I forgot you have hot reload on.
Okay.
I made the ball speed faster though.
Okay. Oh, jeez. Come on, bricks. That's not gonna make it any easier.
Okay, I'm gonna make it one. I'm gonna make it one brick.
Okay. We are. I mean, okay. So, where did you adjusted the speed inside of the ball, or
Yeah. The initial velocity.
okay? Did you just make it less?
No more.
Okay.
But what we really want to do is come down here to create bricks.
Okay.
And just return a single brick. Where is that function? So in bricks per row, we really want that to just be 1 right now, and rows 1. So save that.
You win. But we need to do that after, because right now it didn't actually disappear. The brick.
Oh, it didn't disappear?
Right. So we need to work on the logic in our draw function. Like.
Well, so we just have this the bricks going through the loop.
Yeah, we need to do like checking the game state at the very end. There. Because that way it would have done all of its updates and like disappeared. William's saying, great stream, paddle location.x equals ball.location.x minus paddle. Wait, for testing, this would automatically move the paddle to hit the ball automatically. That'd be pretty cool.
Oh, like an AI, to create a little AI.
A little AI. Still didn't do it. I think it's because we have to do one more update.
Well, it's because we're immediately setting it to the game state to not playing, right? As soon as we finish that.
I see. Also, we're paddle.display. Are we doing ball.display? Actually, we should not display the ball if we're colliding.
So the ball disappears for 1 frame?
Yeah. So here's what I'm doing. If the brick.
I was gonna say.
Yeah.
The
So
ball disappears.
if the brick collided, we don't even display it. But if it didn't, we do display it. And that, I think that should do it. Yeah. Cool.
Perfect.
Cool. We did it.
We have a game.
Oh, Danny Fritz in the chat. Is Brooks gonna make P6 processing in Rust?
Oh, jeez.
That would be really hard, I think. Let me play my soundboard real quick because victory. We did it. Cool. Let's just do a quick rundown of what we built here. Let's pick and choose. So you give a rundown of what's happening in this file, and then I'll do brick, and then ball. Well,
We'll figure it out. Okay.
So let's go.
So I think also like a really quick preview of our indexed HTML, because we've only seen that at the very beginning of this entire thing, which was we don't need anything inside of the body. All we're doing is bringing in a bunch of JavaScript files, specifically P5.js, just the basic P5, and then all of our class files, and then the primary brick breaker file. And once we have that in brick breaker, we have two primary functions that really are doing stuff: the setup function and the draw function. And those are functions that are automatically run or executed by P5 for us. And inside of that, we're in setup, we're telling it to create a canvas for us. And then we're able to initialize sort of the state of the game. So this is where we say, like, well, we get to choose what the colors that we're going to have each brick are, what the state is. We're going to create the paddle and the ball, instantiate them from the classes, and then also go out and create all the bricks. But they haven't displayed yet. They're just sitting there in memory. That's where the create bricks comes from. Now we do have these, that's where the draw function comes from. We do have these create colors and create bricks functions that allows us to abstract away the creation of these arrays, so we don't have to have them inside of the setup altogether. Now down in ball, we get to check our game state. If we're playing the game, we're going to run all of the code that allows us to play. Like, for example, setting the background to 0, which since the background didn't reset, I think that I was wrong, that it would have reset. It's sort of sticking around. So I actually could probably move background 0 up into setup. But here's where we tell the ball, okay, every single frame, check to see, are we bouncing off the edge? Are we bouncing off the paddle? We check, hey, is the left arrow key down or the right arrow key down? If it is, we tell the paddle, go ahead and move. Then we reverse through the bricks array. Now we do reverse here because if we didn't, when we removed it from the array, we'd have this weird problem where our array isn't the same length anymore. But if we go in reverse, we'll never have that problem. So if the ball is colliding with the brick, remove the brick, increment our score, and tell the ball to reverse its y coordinates. That's all down here. Yep. Also, we say, like, hey, if you're being hit, just don't display either. Now, we then tell the paddle to display and the ball to display. It might be nice to sort of put all the displays together in one area, but that could be, a refactor that we do later. Then we have our score. We put this at the bottom because it just like CSS, it loads these in from top to bottom in the file. So our score is now going to be on top of all the bricks. And then we sort of have our sort of game finishing queries here. If the ball is below the bottom of the screen, we've definitely lost. So we switch the game state to lose right here. Otherwise, if all the bricks are gone, then we've definitely won. So we can change the game state to that. Now finally we have that else, and it's a little bit hard to read because that if is so high up there, but the else is basically if we're not playing, then we're in some other game state. And that's where we can say, okay, we'll set the text to really big, and then we're running a, I always forget the name.
Ternary.
We're running a ternary, sort of not how it's supposed to be used. They're supposed to be for returning values, but instead we're using it to set what the next text is going to be colored as. And then we just print that text to the screen. And then that's the entire main logic of the game.
Definitely.
Let's go take a look at ball.
Cool. I'll run through this one. So, and you can see where ball is being used. Like when the game starts up. Well, actually, let's do paddle first because ball takes in paddle. So paddle, when we create a new one, we have like a set width and height inside the constructor. We make it white. We set its location to be the center of the screen and then a few pixels off the bottom. So you can see like that's the paddle there. And we give it an initial speed, and this is going to be the amount that it moves either right or left whenever we move it. And so right speed is positive, left speed is negative. When it's displayed, we set it to be the color, which is just white, and then we draw a rectangle starting at the location, and this is the top left of the square. So we're saying start there. We're going to go to this dot width, which will put it to here, and then this dot height, which will say draw the full rectangle like that. Let's take a quick break before we finish describing. Danny Fritz says ternary, like the common tern. Not quite sure what that means.
I'm wondering if there's a history of the word turn.
Yeah.
That I don't know.
But one thing to think about is because this has this loop like this, draw is getting called like multiple times. So you'll notice for paddle, our display is just simply putting it wherever the location is and the given height. So if the location changes, when draw runs again, it's going to be redrawn somewhere else. And then we have a simple move. So you pass in either left or right, and then location is a vector. So we're going to add, we have a vector that is that specific speed with no y, but it has an x property. And we're going to add the speed vector to the current location. So if we're moving right, it moves right. If we're moving left, it moves left. And then this is just a little bit of edge collision detection to make sure that the paddle cannot, well, let's put back the number of bricks. Let's do like, let's do even more. So let's do 10 rows and 10 bricks per row. Wow. Lose. And also I'm going to decrease the ball speed because Brooks increased that on me. Was it like 5 or what?
It was like 5 and
okay.
negative 5.
It's negative 5. Cool. But what I was going to show is notice the paddle cannot go any farther than the left or any farther past the right. Yeah, and that's pretty much it. So like check my current location. If it's less than 0, then make it 0. Check my current location. If it's greater than the width, make it or greater than the width, then make my x the width minus my width because the location is the top left. Cool. And I guess the last thing you can talk about at Brooks is the ball.
Well, there's also brick too.
Okay. I'll go over brick and then you go over balls.
Okay. Ball. Did you want to do brick now or?
Talk about the ball.
Ball. Okay. Ball is probably our most complicated class, and that's just simply because it's like moving. It's doing all the work for us, literally in our game. Now, when we instantiate the ball, we pass in the paddle just so that we can know where it is, so we can position the ball initially with this create vector using the paddle as a reference. However, we do use it 1 or 2 more times later, so we just sort of kind of store it aside, here. Now, this isn't taking any extra memory up because we're only storing a reference to the paddle. Now, we also set like the size in the radius. Now, this is sort of like caught us off guard because the size of an ellipse is actually the full diameter. So we kind of set the radius and then the size is the radius times 2. Set the color, create an initial velocity, which is again another vector, and store off that paddle. Now we have all these methods on here, like bounce off the paddle. So are we within the width of the paddle? And this is that bounding box rules where we're saying, hey, if our x, if we're in the band of x, so left and right, and also if we're in that y height of the paddle. If we're in there, then reverse the y of the ball, and also reset the ball to be just 1 pixel higher than the paddle, so it doesn't immediately hit again, and reverse right back down. We had a few of those interesting ones earlier on in the stream.
Let's see what happens if we don't do that.
So it'll work up until it doesn't.
Just like everything. I think, yeah, but basically, like, the moment it started off, it, like, just was, like, jittering because it was, yeah, so we had to move it up a little bit. Or I think it just, like, went in the reverse direction. Cool. And then talk about bounce edge.
Yeah, so then we have bounce edge, and this is where we're going to say, hey, is the ball to the right or the left or the top of the entire screen? Well, in this case, it's not screen, it's the canvas that we have. And so we don't check the bottom because that's a completely different state that we handle later. But here we're just checking to see, hey, if the location, and then we're using this plus radius, minus radius, because we really want to see is if part of the ball, if like the right-hand edge of the ball has hit the right edge.
Because the X for an ellipse is the dead center?
Yeah, it's the dead center.
Yeah.
And it's really easy, like with rectangles, if we had a rectangle ball, we'd have to do more math for that, but that's only because it would be from the top left.
Right.
And we created this reverse coordinate just to make it easy to reverse the direction of the ball. And then, well, that's just an abstraction here that we see. In display, it's exactly the same that we saw with paddle. We're just choosing the color and then using ellipse instead of rectangle. We do need that this.size twice because otherwise it just doesn't know what to do.
Because that's the width and height of the ellipse.
Right.
And if they have the same thing, then it's a circle.
We also need to use the fill for color every single time because if we don't, it'll take the last time that we created a color and use that one. And it would be really fun to watch the ball change color with the last brick that it hit, or the last thing that it hit.
Or it was really the last. Let's do it. So if I comment that out, it's the last thing that got colored.
Which actually is white because it's not.
And I guess we're not.
Whatever was the last rendered and created, because when the ball is instantiated, what was the last thing to have color? And I think that was like the score or something.
Okay. Cool.
So yeah, not as awesome as hoped it would be. But like for example, you could make it every frame change a color with a random color, which would be interesting, but not all that helpful. Update. All update is doing for us is moving the ball for us. And we're using vector math here where we say, okay, this location.add, and then we pass it in the vector. That's just adding locations x to the velocities x and locations y to the velocities y. Reverse we went over, and then below bottom this is just returning a Boolean. Is the top of the ball below the bottom of the screen? And if it is, well, then just return true.
And that is used in the draw function because that's where we actually determine if the game is over. So if it's below the bottom, you lose. And then the last thing is the brick. So we do have this function that where we set number of rows, number of bricks per row, and then the width of a brick is going to be the total width of the screen divided by the bricks per row. And then we just have this nested for loop that's going to create basically each row. And for a brick, we pass in the location, which is the x is the current x times the width of the brick, and then the y is the height times the current row. And then we pass in the width, the height, and then some random color from the colors array. And then our brick itself takes in those things and just sets it on itself. And right now we're just setting points equal to 1, but this is a place where you can, in the future, make it more points, or make, you could even add logic to make a brick harder to break. Like maybe instead of just immediately breaking, it has like a counter of how many times it needs to be hit before it breaks. I don't know. But right now, that's just basic setup. When it gets displayed, we display a rectangle at its current location. And then we just have the bounding box detection. So if the ball is anywhere within the brick, then we return true. So we check if it's colliding. And this is the... do you call this bounding box? Or
yeah, I think it's like AABB bounding box. Danny could tell us. And also, Danny says, this is a really good rundown of game development. With this knowledge, you can make probably most 2D games,
Yeah.
which is true. I mean, a lot of people think that, well, especially collision detection is the thing that scares the most people into using really heavy frameworks. And in this case, we have rectangles and circles. They're the easiest to do collision detection on, and it's as easy as just these four if conditionals.
Yeah. And I guess that's an interesting thing to note. Like, P5 isn't necessarily for creating games. It's for, like, working with the canvas in HTML5. But because it has this draw loop that, like, runs a certain number of frames per second, you can treat it like a game. Like, on each frame, update the location of things. And update location based on velocity, or update location based on if key is down or if mouse is pressed. And, that's great.
And Danny said it's the name for this pattern is AABB, axis aligned bounding box.
Cool. I'll throw this in the comments so you can Google it later if you want to. AABB, axis aligned bounding box. He also says it is the cheap collision detection you can do for rectangles that are aligned on the same axis. Anything more complicated would need the separating axis theorem. And right now we're dealing in serious 2D, like just boxes. I guess right now we're doing like crude detection of like the top edge of the circle. If we really wanted to be complex about it, we'd want to check like the curve of the circle, right? Not necessarily just the top of the circle.
Well, I mean, yeah, but like even then it wouldn't be too hard to do with circles and rectangles. It's more of if we don't have a rectangle, if we have like a weird diamond shape.
Did you see what happened though? So like because it didn't immediately repulse, it just like went straight through a bunch of bricks.
Well, that's because it hits one brick and then immediately hits another brick. So it did reverse, but it reversed within one frame or two frames.
I see. Cool. I think that's it. Anything else we should talk about, Brooks, before we end the stream, or?
I mean, so we've got all the things that we wanted to get done. Like the ability to like have different bricks be different points is as simple as when we call the brick, like call it with something else so that it knows that we can set the points on the bricks to be higher than 1, and then our scores would just magically auto update with that.
Yeah.
We could like give them health to do harder to destroy. You could do things like there's power-ups inside of the bricks that then fall. You can change the animation of how bricks are destroyed so they don't just disappear, but like explode into a bunch of fragments. There's so many things that could be done here, and all it really takes is like build this as a template and then sort of fork it off of here and try it out.
Yeah, so I'm going to push this code up to GitHub. I'll put the link in the description so you can fork it and try it out yourself. SDFGWDH says, great stream, guys. I learned quite a bit. Quick plug for the coding train. So he has a live stream where he does all kinds of things with P5.js, and he builds games all the time and just like cool visualizations. So like sometimes he uses processing, sometimes he uses P5. But he built Pong, he's built like 2048, and using the same framework that we just used. So if you're interested in this stuff, check it out.
I learned actually how to use P5 from watching Coding Train's videos.
Yeah. Leanne says, happy birthday, thanks. So actually my birthday is tomorrow, which I will talk about. So I normally stream Monday evenings, but because tomorrow's my birthday, I'm not going to be streaming. But I will be back for Newbie Tuesdays. If you check out my channel, you can see the upcoming streams. So tomorrow, we're going to be doing higher order functions for Newbie Tuesdays. We're going to try a different format. We don't necessarily have a project to do, but I'm going to like introduce a higher order function and then try to see if Tony can use it or like convert an existing function into it. Code Kata's on Wednesday, morning tea on Thursday, and Thursday evening, I am going to be doing an intro to GraphQL stream. William has been coding along. Awesome. And Paradise says, I know you through his channel. Yeah, so a while back, not a while back, maybe a week or two ago, Coding Train gave me a shout out on his stream. I didn't know what to say. I didn't know, like, how the heck did he even find me on YouTube? But yeah, he's awesome. Brooks, let's talk about your channel. Anything else you want to plug or?
Well, yeah. So I do have a channel. I do stream. I have a YouTube channel at Brooks Builds.
Brooks Builds.
I don't have quite as many subscribers as CJ. But recently, I've been streaming myself learning Rust in the morning. That's the only time I really have to do a solid 1 hour stream, consistently. And that's me going through the Rust book and just reading that. So if you're interested in like a systems language, I highly recommend taking a look into Rust. You can begin right at the beginning of a playlist, Learning Rust, that I have. It starts like with basically zero knowledge of Rust required for that. And then I stream on Twitch TV, and that's where you'll see me actually do the streams, and the archives come over to YouTube.
Yeah, so I'll share that too. And you're currently hosting Bob Ross, I see.
Yeah, I do auto-host some other streamers, but Bob Ross is such an awesome... he was so awesome with his like painting and just sort of thought process of creativity that I couldn't help but host him whenever he's on.
Yeah. Cool. Do you have a Twitter where they can follow you, or is that?
I do have a Twitter. Okay. It is on my various descriptions, but it is Brooks_Patton.
Cool. And do you tweet there when you go live?
I do tweet usually the night before I go live because it's really early, and then sometimes I go live randomly.
Okay.
So if you follow me on Twitter, you'll find out when I'm going live randomly, or when I'm about to, when I'm planning to go live, or also just follow me on those various channels on Twitch or YouTube to find out as well.
Awesome. And Aaron Goodman in the chat says hi. Hello. You caught us right at the end of the stream. But as I mentioned, we're going to post the code as a link in the description so you can check it out, fork it, make it your own. And I think that's it.
If you guys do anything with this code, like create something unique and new that's different from this, I would love you if you tagged us on Twitter and tweeted a link to it on YouTube or just in GitHub so we can take a look at it.
Yeah, I think the easiest thing would be open an issue and like post a link to your fork. But that'd be awesome. Like on an upcoming stream, we could look at some of the things that any of the viewers did to our code base. Cool. This has been really fun, Brooks. High five. Yeah. Ooh,
no, it's been super fun.
Wait, do that again. I want to see how it looks on the camera. Okay.
Sort of.
Come a little more this way. Wait, I'll go that way. That way.
There.
Cool. Thanks everyone for tuning in. Thanks for participating in the chat. Yeah, so I talked about my upcoming streams, but if you do check out coding.garden, you can see my full streaming schedule. And yeah, I think that's it. Wherever you are in the world, have a wonderful morning, afternoon, or night, and I'll see you next time. Here is this.